Hey everybody, I'm back to record a video for lesson 10.4. I appreciate those of you that turned in the first packet, and I know you got these last week, so maybe I'm a little late posting the video, but anyway, here it comes. Let's get started with chords and arcs. So first of all, we've got to remember from a previous page in the packet one. A couple of definitions. So a chord is a segment that has endpoints on the circle. So in this example, we have chord AB because we have endpoints on the circle here, A and B, and here's another chord, CD. So there are two chords in this figure. And then an arc is a portion of the circle. So like the curved distance here, so from A to B, it's like kind of think of it as like a segment of a line, but as applicable to a circle. So it's like this curved segment of the circle. AB is a chord, CD is a chord. Excuse me, not chords, arcs. AB is an arc, CD is an arc, BD is an arc, AC is an arc, AD is an arc. So we have sort of like portions of the circle all the way around the circumference. Okay, so a couple of properties about congruent chords and arcs. Okay, so first we have two chords are congruent if and only if their corresponding arcs are congruent. Okay, so first of all, their corresponding arcs have to be congruent. So we're looking at the chords AB and CD. So we can say chord AB is equal to or congruent to CD if and only if the measure of arc AB is the same as the measure of arc CD. Okay, so the corresponding arcs. Let's talk about that for a second. So we have the chord AB, and the arc that goes with that would be arc AB, right? So we're saying if AB, chord AB is equal to chord CD, then the arcs AB and CD also have to be the same. Their measurements have to be the same. Now, this is biconditional, so that means it has to be both ways. So if this, then this, and if this, then this, right? We go both ways. So the chords are equal if and only if their arcs are equal. Is it kind of a short way to say it? Okay, the other thing that we know is about the two chords. They're congruent if and only if they are equidistant from the center. They're equidistant from the center. Okay, so AB is equal to CD. Those are the chords, AB, CD, if and only if EF is equal to EG. Okay, now that's the distance from the center to the actual chord. So we're saying these chords can only be equal if their distance away from the center is equal. Okay, so that tells me that, like, if we're given that the chords AB and CD are equal, then we instantly know, because of the biconditional statement, that EF, this segment, has to be equal to EG, the segment EG. Okay. Also, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. Okay, so we have some radii in this circle that are perpendicular to a chord, right? That's what these right angles tell us. So I have the radius EH perpendicular to chord AB. Okay, so what this statement tells me then, because I know that it's perpendicular, based on the little right angle symbol, then I know that, well, let me write that. So EH perpendicular to AB, if that's true, then AF is equal to FB, or in other words, it's bisected, right? And then the same thing with the arcs. So we can also say that the measure of arc AH is equal to the measure of arc HB. So these little guys here are congruent to each other. Now, same thing down here. I'm just not going to write it again, but because we know that the radius is perpendicular to the chord, it bisects the chord and it bisects the corresponding arc. So CG and GD are equal to each other, and the arcs DI and IC are equal to each other. All right. So now we can apply those ideas and work a few problems. We're going to work number 1, 3, and 5 on this page together, and I'll leave the other ones for you to do. Okay. So number 1, when we look at it, we are given some arc measurements, right? And we're supposed to find x. We're also given these tick marks on the two chords ST and SR. All right. So up above we said if the chords are equal, then the arc measurements are equal as well. So then I can write the equation 7x plus 24 equals 115. And if I subtract 7x from both sides, if I subtract 24 from both sides, I get 7x is 91, and then divide both sides by 7, so x would have to be 13. So in this problem, x is 13. Okay, not too bad. All right, let's look at 3 and then 6. All right, so for number 3, it's kind of the opposite. I'm given that the arcs are the same. Okay, well, if the arcs are the same, then the chords are the same. So we said that earlier. So I can write the equation 9x minus 34 is equal to 4x plus 1. Okay, so if I combine like terms by subtracting 4x from both sides, I would have 5x. And then I can add 34 to both sides. So 5x equals 35. Divide both sides by 5. X is 7. Okay, but here the question was to find xy, so we want to know the actual length of the chord. So I can say that xy is equal to 4, plug in 7, plus 1. 4 times 7 is 28, plus 1 is 29. Okay, so the length of the chord is 29. And that's also the length of this chord. So really, since we knew they were equal, we could have plugged 7 in here as well. 9 times 7 minus 34 is also 29. Okay. Let's look at number 5. So we're asked to find x, and here we're given, okay, so that two chords are equal. So we have two equal chords. We know then that their arcs are also equal. So really, I could do this a couple of different ways. This arc up here is also going to be 7x minus 20, or excuse me, 6x minus 20, because they're the same. And then we are given this arc is 76. Okay, well, I know that a circle has to be 360. So there's a couple ways to do this, but my first thought is, what if we take 360 and we subtract 76? It's 284. Okay, now 284, so I have two of these that have to both equal 284. Alright, so 7x, I keep saying 7, 6x minus 20. I don't know why I wrote 24. That would be 284. Sorry about that. Has to equal 284. So the first thing I'm going to do is divide both sides by 2, so that I find out that one of these sections, just one of these sections, has to be 100 and 42. Okay, so then I can solve the problem. I can add 20 to both sides. So 6x equals 162. And if I divide by 6, I get 27. So x is 27 for that one. Okay, numbers 2, 4, and 6 are all three pretty similar to 1, 3, and 5. I think you can probably get through those on your own. Okay, so if we move over to the back, I'm going to do a couple problems on the back, and then we can wrap this video up. So let's skip ahead to number 10. Let's look at number 10. See if I can zoom in on that a little bit. Okay, so in circle I, in this circle, if BG, now let's find BG, it's this little section right here. Try to color it red. If BG is 17 and the measure of CHA is 256, okay, CHA, start at C, you go through H, around to A, it's all that. So that's 256. Alright. And then we said that BG, that little section, was 17. Okay, so if we know those two things, find all this stuff. Alright, well, let's see. Let's just go one at a time. BC. BC is this whole length, right? So if we go back to the notes we wrote at the beginning of the video, because we have this radius perpendicular to the chord, we know that it bisects the chord. So half of the chord from B to G is 17. The other half is also 17. So 17 times 2 is 34. So we just found that BC is 34. Okay. Now FB. Okay. FB is also half of the chord, and we've already said that the chords are the same, right? They're both bisected. So FB also has to be 17. Okay. The measure of angle AB. Let's see. I don't know if I can answer that quite yet. Let's see. Okay, well, yeah, we can do it this way. So if we know that the entire circle is 360, and we know this big blue portion is 256, right? So let me subtract that and see what's left. 360 minus 256 leaves me with 104. All right, and then arc AB would be half of that, right? Because these arcs are the same. So then half of 104, I should write that. 104, and then if I divide by 2, I get 52 degrees. So the measure of AB is 52 degrees. That also has to be the measure of BC, 52 degrees. And then EC is just half of that arc. So half of 52 is 26 degrees. So we just had to, it's basically the same as the other problems. We were just looking at it at a different angle, no pun intended. But they give us this entire arc, 256, so we have to subtract to find what's left, and then we know that those two arcs have to be equal because we have chords that are the same distance. See the congruent radii? Radii are always congruent, but since we know that they're the same distance away from the center, then we know that they're going to be equal to each other and they're bisected. Okay, let's see. Number 12. Let's look at number 12. Alright, so if the measure of arc CI, that's this one right here, CI, is 7x minus 15, and the measure of EF, the whole thing, so different color, I'll make that one blue, is 12x minus 8. Find the measure of CI. Okay, so to do this, we're going to have to find x. Now, notice that over here we have the entire arc. Over here we have half of the arc. Okay, now back up. I know that these arcs are equal. to each other. Okay, from the previous notes, we've got they're perpendicular. The chords are perpendicular. I know that because of the right angle symbols. I know that they're equidistant from the center. It tells me that the chords are equal. And then the first thing we wrote in the video was if the chords are equal, then the corresponding arcs are equal. However, this one I only have half of, so I need to double that to make it equal to this one, because over here we have the entire thing. All right, so I'm going to write 2 7x minus 15, because we have 2 of those, equal to 12x minus 8. Okay, so we can do this a couple ways. If you distribute here, this would be 14x minus 30 equals 12x minus 8. Okay, we can subtract 12x from both sides, so I'll have 2x minus 30 equals 8. Negative 8. Then I'll add 30 to both sides, so 2x equals 22. So x is 11. Okay, x is 11. Okay, but I was supposed to be finding ci, this little part, so I'm just going to plug in. So 7 instead of x, 7 times 11 minus 15. So that's 77 minus 15, which is 62 degrees. Okay. Now let's do 13 and 14, and then I'll leave the rest for you guys to work on. Okay, let's see if I can get straight on my screen here. There we go. Okay, so looking at this circle here, we've got to answer the 2 questions. Now, 13 through 16 are kind of a throwback to some previous lessons, so you're going to have to kind of stick with me for a minute as I recall some older material. For number 13, we're supposed to be finding VW. All right, let's see, where's V? Here, the VW. So basically the length of the chord. Okay, but we're not given any arc measurements, so that's the reason. Like we got to kind of think outside the box a little bit on this one from what we've been doing in the rest of the lesson. But I do see a right triangle, and I do see that I have 2 sides of the right triangle. So this is making me think about some of the trig functions that we did earlier, and in this case particularly, I would use the Pythagorean theorem. I know, okay, back up. So let's tie it to this lesson. Because of the perpendicular angle here, that tells me that these 2 are bisecting, or excuse me, well, they're perpendicular, so the radius bisects the chord. So if I find this side, which it happens to be a leg of the right triangle, I can double it to find the entire chord. Okay, so it looks like if I'm thinking Pythagorean theorem, I can write a squared plus 5 squared equals 13 squared. So a squared plus 25 equals 169. A squared would be 144 if you subtract from both sides, and then if we take the square root, a is 12. Okay, so then this part is 12. So then if I double that, the entire thing would be 24. So VW would be 24. Okay. Number 14 is using the same circle, but it's not really related to the first part of the problem. So let's see. We got find the measure of arc YW. Arc YW is this one. Okay. Okay. So if you go back to maybe lesson 10.3, where we were talking about central angles, we basically said that if we can find the central angle measure, so that's a central angle, its vertex is at the center, right? See that? If we can find that measurement, then the arc is always equal to its central angle, the corresponding central angle measure. So let's focus on finding that. Okay, well, if you think back, like way back, maybe like from the lesson, chapter 8 lessons, we did the earlier videos from the first packet. How do we find missing sides or missing angles of a right triangle? We said we use trig functions. So we know that we're looking for this one here, and I have an adjacent angle to it, and I have the hypotenuse. So that's a cosine problem. So we can say the cosine of x is equal to the adjacent, which in this case is 5, the adjacent side is 5, over the hypotenuse. Okay, now this is actually an inverse trig function because we need to isolate this for x. So to do that, we're gonna use inverse cosine. Okay, so I can rewrite this as x equals the inverse cosine of 5/13. Okay, now this is where I grab my calculator, right? And I type in 5 over 13, or 5 divided by 13, and get this big decimal. And then I'm going to type in second cosine. So that will take the secondary function, or the inverse function of cosine. And that gives me the answer. I'm just going to round here to the tenths. So I get that x would be about 67.4 degrees. All right, and now remember that's a central angle. So the central angle is going to be equivalent to the arc measure. So this here is also, I'm just going to write it like this. I'll come down into I'll run out of space. So I'll say the measurement of YW, and put the little arc symbol over the top, is also equal to 67.4 degrees. Okay, now there was a lot in that. It's not very difficult, just solving some basic equations through this lesson. I'm going to give you some time to work through that. There's a homework assignment following this lesson that you can work through and work on some stuff. I had several emails and messages asking again, do we have to answer every single question in the packet? And the answer is no. It's there for your learning, and just so you have the opportunity to look at some different stuff. I do think, once again, it's a good idea for you to work through these as much as you can. But by no means do I expect you to do every single problem. So don't worry about doing that. In this lesson or in the homework to follow before we get to 10.5, if you have questions, please don't hesitate to shoot me an email or a message through the Remind will be fine. And I look forward to hearing from you guys. Take care.